Hello, this is Mr. Wynn. Today's video will be using exponential and logarithmic functions in real life. So, scientists and researchers use a different formula for growth and decay than lesson 7-1. That is because we usually have continuous growth and decay. Alright, so here's our equation. So basically y equals ae to the kt for growth, y equals ae to the negative kt for decay. Again, negative exponent means decay, positive exponent means growth. Now this formula is the exact same as we did from last section, the continuous compounding money. Remember a equals pe to the rt? We just replace it with y equals ae to the kt. So usually I just memorize one of them and I use it. I always know that p is my starting amount, a is the total left over, r is still interest, and t is still time. So r is the rate. Alright, so we're basically going to find k. Alright, k is a constant. It's going to be the rate of growth, or it's going to be the rate of decay. It's still basically our rate. Alright, so example 1, the half-life of a radioactive substance, the time it takes for half of the atoms to disintegrate. The half-life of carbon, 14, is 5730 years, 5,730 years. Find the value k and the equation. Alright, so our equation is going to follow this, a e to the kt, and we don't worry about that negative sign. If k is negative, then, well, if it's going to be negative, k will be found as negative. Alright, when you do half-life, it didn't give us a starting amount. You can make up your own. I'll say if the starting amount is, say, 100, half of it means it's 50. You can pick your own. Some people use 1 and 2, some people use 10 and 20. The book does 0.5 for y and 1 for a. But I'll use 50 and 100, that's easy. Right, e to the k we do not know, but t is the half-life, so I'm putting 5,730 years. Right, now I'm going to solve for k. So let's get rid of this 100 first by dividing by 100. Alright, so this is basically 0.5, or you can leave it as 1/2, your choice. But no matter what numbers you pick, it should be 0.5 if you're trying to find k. Now this is e to the 5730k. Alright, I got to bring that k down. I have e, so I'm going to ln both sides. So ln of 0.5 equals the ln of e, and we have this exponent. Using the property of logarithms, well, this cancels. You can always bring exponents down. So let me go over here. Alright, so I'm at ln of 0.5 equals 5730k. All I do is divide by 5730 to get k. Alright, now that's our exact answer, ln 0.5 over 5730, but let's just find the decimal. Now k is going to be a long decimal. Let's see, k is ln of 0.5, and this is a fraction. ln 0.5 over 5730. I get k equals that. Remember, e to the negative 4 means go left 4 decimals. So if I go left 1, and the 3 zeros, k is negative 0.3 zeros, and then 1, 2. I do that. Alright, so that's k, and then I technically put the 0968 if I want. There's my k. All I do is plug into the equation, then I'm done. So I know y equals a, we don't know the starting amount, e to the k, we know k is negative 0.00012 t. Alright, see how it's a negative exponent? That's why it's decay, it's disintegrating. And we're done. Alright, so I could tell you, give you a starting amount, you could tell me after time how much is left over. Example 2. A paleontologist examining the bones of a prehistoric animal estimates they contain 2% as much carbon-14 as they would have contained when the animal was alive. How long ago did it live? Alright, see, it's the same carbon-14 as before, so they would have told me. So we're going to use the same equation we had right here. So y equals ae to the negative 0.000012t. So y equals ae to the negative 0.00012t. Alright, so that's my equation. Now I'm going to fill in what I know. it has 2% as the had now as much as live there. Right. So say it started out 100. There's only 2% left. So that's 2 for the amount now and 100 from before. E to the negative 0.00012t. All right. Well, we're going to solve for t. Get rid of this 100 by dividing. And that is 1/50th, or the decimal, 0.02. Basically 2% instead of half, 50%. E to the negative 0.00012t. Got to bring that exponent down. I'm a log both sides, but since e, I'm an ln both sides. ln of 0.02 equals ln of e to the negative 0.00012t. Remember, ln of e cancels. This goes down. So I should go up here. So I'm at ln of 0.02 equals negative 0.12312t. And then I'm going to divide to solve for t. Divide both sides by negative 0.00012. Divide negative 0.00012. So t equals ln of 0.02 divided by negative 0.00012 is the exact answer. They want the decimal, or it's actually going to be a nice number. Not a nice number, it's going to be a big number. ln of 0.02 divided by negative 0.12312. 32,600. And I'll just do that. That's a big enough number. 32,600. Remember, t is always in years. All right. So this is how old this animal lived, or how old it really is, this bone or fossil is. There's only 2% left over from before. It's 32,600. This is how they figure out how old fossils are. All right, this also works for continuous exponential growth. Remember, continuous basically is this formula, y equals ae to the kt. We're going to use Texas population now. So in 2012, the population of Texas was 26.06 million. In 2000, it was 20.85 million. Find the value k, Texas' relative rate of growth. So y equals ae to the kt. We're going to figure out how much we started with, which is our 2000 point. So in 2000, we started with 20.85. So let's start there. 20.85 e to the kt. That's y. All right, that 2012 and 26.06 million, that's going to be our point we're going to use to find k. All right, so I'm going to go over here. So y is our new population. So basically 12 years later, it became 26.06 million. Our original amount was still this. E, k we don't know, but t was how many years has it been since before? It's been 12 years. All right, I got to get rid of that 20.85 by dividing it. And I'll use a calculator for that. So let's see, 26.06 divided by 20.85. I get, let's just round it to 1.25. Close. Yeah, let's do 1.25. All right, so I'm at 1.25 on the left side equals e to the 12k. All right, I got the exponent down, so I'm at ln both sides. ln of 1.25 equals ln of e to the 12k. Remember, ln of e cancels. This is just 12 cancels aside. So I'm at ln of 1.25 equals 12k. All I do to solve for k is divide by 12. So k equals ln of 1.25 divided by 12. Fraction ln 1.25 divided by 12. I get 0.0186. 0.0186. 0.0186. Is that right? All right, that's k. That's our rate of growth or decay. Since it's positive, it's growth, and that's about 2%. Come on, that's really r. So basically, it's Texas is growing at 1.8% per year. So fill it in, then we have our equation. So our real equation is y equals 20.85 times e to the 0.0186 t. There's our equation. Now the second part is, when will Texas have 30 million people? So we have our equation from before. Y equals 20.85 e to the 0.0186 t. They're asking, when's it 30 million people? That's our y. So they're saying 30 million. Remember, we're always in million units right now. 0.85 e to the 0.0186 t. Well, I'm going to divide by 20.85. I'm just solving for t. All right, use a calculator for that. 30 divided by 20.85, 1.4388. Let's just keep that. 1.4388 equals e to this number. I'm going to ln both sides. ln of 1.4388 equals ln of e to the 0.0186 t. Remember, ln of e cancels. This goes down. So I'll be over here. So I'm at ln of 1.4388 equals 0.0186 t. Solving for t means I divide by 0.0186. 0.0186 t equals, let's find the decimal fraction of ln of 1.4. Bottom is 0.0186. 19.56 went up. 19.56 t is years. Alright, so in about 19 and a half, I'll just say 20 years, Texas should have 30 million. So basically in the year 2020, Texas should have at least 30 million people, according to this formula. Alright, here's your practice problem. Solve for t in that. That's the decimal answer. So good luck. If you can do that, you should be fine in class. Again, this is Mr. Wynn. Thanks for watching. See you later. Bye.